Welcome to the presentation of our online course, Life Cycle Assessment of Bioprocesses and Bioproducts. Through our bioprocess engineering online courses, you will master the principles of bioprocess design, scale-up, and optimization, with applications in enzymatic bioconversions, microbial fermentations, and animal cell cultures. For more details, visit us at bioprocessdigital.com. Life Cycle Assessment, LCA, is a methodology used to evaluate the environmental impacts of a product throughout its entire life cycle. LCA examines the effects of material and energy resource consumption, as well as the emissions released into the air, water, and soil. The primary objective of life cycle assessment is to assess the environmental consequences of a product from its creation to its disposal, a process commonly known as cradle to grave. This course provides a comprehensive overview of the standard methodology of life cycle assessment for evaluating the environmental impacts of products or processes. You will begin by learning the core methodologies of life cycle inventory, LCI, which includes compiling material and energy inventories, and life cycle impact assessment, LCIA, for evaluating impact indicators. The course will guide you through interpreting LCA results, focusing on product footprints, sensitivity analysis, and uncertainty analysis. You will also explore advanced topics such as impact allocation between products and byproducts, as well as conducting comparative LCAs of products with similar functions. Finally, you will examine strategies for environmental optimization aimed at reducing impacts. The LCA methodology will be taught through a case study on the production of bioethanol from sugar beets. The life cycle of bioethanol includes the following stages: the cultivation of sugar beets, the transportation of beets to the industrial plant, the conversion of beets into ethanol, along with the processing of byproducts, the transportation of both the ethanol and byproducts. Finally, the combustion of ethanol in a car engine. The industrial process for producing ethanol from sugar beets includes the following operations: washing and shredding the sugar beets, extracting the sugar, fermenting the sugar to produce ethanol, distilling the fermentation mash to recover the ethanol, dehydrating the ethanol to obtain a fuel. The ethanol production process generates two byproducts that are treated for valorization. Firstly, the beet pulps obtained at the end of the extraction operation. They undergo two operations of mechanical pressing and drying. Secondly, the distillery residues known as vinasses. They are concentrated through evaporation. The course is organized into 7 sessions: material inventory, energy inventory, impacts indicators assessment, impacts allocation and bioethanol footprint, comparative bioethanol versus gasoline LCA, sensitivity and uncertainty analysis, and environmental optimization for impacts reduction. The session can be taken individually. In Session 1, you will evaluate the bioethanol life cycle material inventory per hectare of beets culture. It includes the quantities of chemicals, water, and CO2 used, the quantities of products and byproducts generated, the quantities of liquid wastes, as well as of air emissions. In Session 2, you will calculate the energy inventory for the bioethanol life cycle, which includes electricity consumption for equipment operations, natural gas usage for heat generation, diesel fuel consumption for powering tractors and trucks. In Session 3, you will evaluate the indicators for 6 environmental impacts: 2 impacts related to resources consumptions, primary energy consumption in megajoules, water consumption in kilograms or cubic meters, 4 impacts related to water and air emissions, global warming potential in kilograms CO2, water eutrophication in kilograms phosphate, photochemical oxidants formation in kilograms ethylene, human toxicity in kilograms dichlorobenzene. In Session 3, you will learn the methodology for calculating impact indicators. This involves aggregating the contributions of all inputs and outputs from the material and energy inventories and applying impact factors sourced from environmental databases. In Session 4, you will learn how to allocate the impact indicators between ethanol and the two byproducts, pulps and vinasses, using the pro rata and substitution methods. In Session 4, you will also establish the bioethanol footprint. This includes analyzing the inventory's contributions to the impact indicators and determining the relative significance of the 6 evaluated impact indicators. In Session 5, you will compare the environmental footprints of bioethanol and gasoline. This includes comparing their individual impact indicators based on their combustion energy. You will also determine a global environmental indicator or score for each fuel. Upon completing the 5 sessions, you will gain access to a powerful LCA spreadsheet simulator. This simulator allows you to predict environmental impacts indicators based on the beets culture variables, the ethanol process variables, and the impact factors of materials and energy sources. In Session 6 on sensitivity and uncertainty analysis, you will use the spreadsheet simulator to rank the influences of technical and environmental input data on the impact indicators. Additionally, you will assess the uncertainty in the evaluated indicators to better understand the reliability of the results. Finally, in Session 7 on environmental optimization, you will use the spreadsheet simulator to reduce the impact indicators of bioethanol. This is achieved by adjusting beet cultivation conditions and optimizing the design and operational variables of the ethanol production process. To support your learning, the course provides recorded slideshow presentations on the LCA methodology, guides for the bioethanol LCA case study covering key concepts, methods, and mathematical relationships. You will also use specially designed spreadsheet templates for your evaluations, featuring a green-red correction system that provides immediate feedback on the accuracy of your inputs. You can progress through the spreadsheet templates independently with the help of a detailed guide, or choose to collaborate with your tutor for personalized guidance and support. You have the flexibility to tailor this online course to your individual pace. Plan and structure the course according to your own schedule. Additionally, coordinate the interactions with your tutor through video meetings. For further information on the course, please visit our Bioprocess Engineering online website or contact us at bioprocessdigital.com.